open source overlay protocol that enables creation and interoperability for value transfer networks. And if you ask us, is GeoProtocol a layer 2 solution? We say yes, definitely. And there are two main reasons why we decided to organize this event. First one, we do want this as a true layer 2 solution. We do understand the importance to gather this community, to share ideas, vision, experience. And the second one, we truly believe that layer 2 solution will help blockchain systems to be more, to create this world for better, I would say. And before we start, I would like to ask you, is there anyone who doesn't know what is layer 2? Oh, that's good.
I know.
You don't know, okay. And you are a speaker, okay.
Because the whole thing is layer 2 is such a general term, it doesn't really say what it is.
Yeah.
Okay, you'll have 40 minutes to discuss it with the other colleagues. Yes, and before, is there any developers in this room? That's good. Tricky question, investors? That's also good. So, who are the rest of you then, guys? Okay, and if we still have a few people here who doesn't know what it is, let me show you a super short video for 4 minutes how we from GeoProtocol see implementation of layer 2 solutions for the future of Internet of Value. So I hope it will be more clear for the rest of you guys.
Over the past 2 decades, we've witnessed the explosive development of information processing and transmission technologies that have revolutionized many aspects of human life, including the economy, as well as our daily lives. At the same time, however, technology for transferring value remains to a large extent at the level it was in the middle of the last century. A significant part of the world's population still have no or limited access to financial services. In Africa, for example, people already have more access to mobile communications than to banking. We believe that following the Internet of Information, the Internet of Value will come about. This is where the transfer of value happens as quickly, easily, and cheaply as the transfer of information occurs today. In addition, the entire global economy and each participant will enjoy the advantages of the network effect. But what still stands in the way of this revolutionary innovation? One of the main reasons why the Internet of Value still remains just a concept is that to date, there has been no technology enabling this to be put into practice. Even the emergence of innovations like blockchain and cryptocurrencies has done little to facilitate this. Blockchain perfectly solves the problem of trust in a payment system. But the trouble is, blockchains are just another alternative implementation of a value registry, which, like all the various value registries we have today, are poorly connected to each other or even not connected at all. In this sense, blockchain-based ecosystems are not much different from traditional payment systems. So today we have many value ecosystems which do not interact with each other, or at least which do so inefficiently. It is almost as if instead of the global internet that connects everything and everyone, we have only a bunch of unconnected or loosely coupled local area networks. And this is exactly the situation we currently have now in the sphere of money and finance, in the realm of value exchange. So how can we solve the problem of creating a global network for value transfer and exchange? Different value transfer networks need a universal solution that provides a technological opportunity to interoperate, to lower the costs, and to accommodate the growing number of transactions with no speed and safety sacrifices. This is exactly the solution that GeoProtocol is on track to deliver by developing a technology which has the potential to become the equivalent to TCP/IP for the future Internet of Value. GeoProtocol is an open-source, off-chain, and easily scalable protocol for cost-effective value transfer, combining both blockchain and traditional finance ecosystems. Geo Protocol solves the existing problem of siloed networks by creating a universal infrastructural layer for seamless inter-network transactions. The ability to digitize any physical and other non-digital assets in Geo, as well as their logistics, opens up completely new and unique opportunities for all network participants. To learn more about Geo Protocol, check out our next videos or visit our website. Geo Protocol, creating a universal ecosystem for value transfer networks.
And moving closer to our main topic and our main guests, I would like to say that we gathered together the most trusted and the most valuable Layer 2 solutions that exist from all over the world. And we are proud to say that we will share this scene with amazing speakers. And I'd like to say in short our agenda for today. So we have first panel, it's Layer 2 panel. Alex Bulkin, our moderator for today for this panel. Then we have a short break for networking and for chit-chatting. And the second panel will be about micropayments. And there is our next moderator, Julien. Okay, so and I would like to introduce one more time Alex Bulkin. It's your time. I'm giving you the floor. And you please introduce our speakers and make it short. Yes, you can.
Hi guys. So it's a pleasure for me to be here today. We work with Geo very closely and generally follow the space. I'm actually very happy to be talking to some people I haven't met before. It's always very exciting. So today we have, I'm just going to call your name and why don't you come up, Harry Kolodner from Off-Chain Labs. Anurag Arjun. Hey, good to meet you. Jason from TrueBit. Oleg from iExec. And Dima from Geo Protocol. So guys, maybe we start. Natalie, give us like a 20-minute wave when just about. So why don't we start by just giving a quick intro and maybe telling us a few words about your project and what it achieves. Why don't we start with you?
Hi. My name is Jason Teutsch, and I am founder of the TrueBit, which is a, well, guess, layer 2, something or other. We do scaling of smart contracts to larger computations. So rather than trying to get a lot of small ones to go through, we do big ones. That's TrueBit.
Hi, my name is Anurag. I am co-founder and chief product officer of Matic Network. We are a layer 2 scaling solution on Ethereum for now. We're based in Plasma. So ours is like a hybrid Plasma plus POS sidechain. So we offer security for Ethereum assets on Plasma, but for POS, we offer smart contract support as well. So it's a really compatible sidechain. Yeah.
Hey, I'm Harry Kolodner. I'm co-founder and CTO of Off-Chain Labs, where we're building a layer 2 scaling solution called Arbitrum. Arbitrum is fundamentally a hybrid approach, kind of combining the best of both sidechains and state channels in order to allow for both efficient, private, and scalable smart contracts that can kind of implement the whole next generation of blockchain applications.
Hi, I'm Oleg Luchansky. I'm the CTO of iExec, and we are working with Polkadot to experiment layer 2 protocol. And we do decentralized.
Hi everyone, I'm Dima Kovalchuk from Geo Protocol. And you know already about what we aim to do. I just want to add that we started at 2015 from the idea of free decentralized payments. And after 4 years of development, we have just announced and launched our beta.
Thanks, guys. So, who can tell me what is layer 2? Or maybe we can start with what is layer 1 and then what is layer 2.
Would that make it easier or harder?
I don't know, it's up to you.
It sounds like you're trying to pick a fight.
Not yet.
How do you know if you're layer 1 or layer 2?
That's right.
Okay.
Do you want to?
I can make it.
You can do that? Okay, go ahead.
Okay. I can say that I think that layer 2 is just another attempt to solve this blockchain trilemma between scalability, security, and decentralization. So it's just like from ideological side.
Cool. Anyone wants to add to that?
Yeah. I mean, to me, the big difference I look at is based around trust assumptions. So what could break and screw you over if you're using this tool? And layer 2 are the solutions where there's kind of none or maybe very little kind of potential for anything to break. Compared to the base layer where you have 51% attacks, where you have in proof of stake all sorts of more complicated issues and all of that to deal with.
Cool. So, wait, you're saying layer 2 is harder to break?
Yes. That layer 2 designs should fundamentally not introduce significant pieces that can be independently broken.
Right.
Because at that point, you might as well be a layer 1 and be building your own blockchain.
Right.
Except in some, there are some exceptions there, but that's kind of broad.
Alright, so everybody here is an expert, and I hear like amazing things. There's some people building Plasma, some people building state channels, some sidechain projects. I'm still not sure what that exactly is.
No, we won't build. We use Polkadot.
Use what?
Polkadot.
Oh, Polkadot? Oh, cool. So,
Isn't it an Oracle thing?
Sorry?
I thought it was an Oracle. Is it also a layer 2?
No, Polkadot proposes a layer 2, yes, with bridges and things like that.
and we also have scalability for both payments and computations, right? So we have a good spread of different ideas. So can we talk a little bit about the difference between the different approaches to layer 2 scalability? Like, if if I don't know what the difference is between a state channel and a Plasma chain, how can I think about it?
Okay, so maybe in simpler terms, when you think about a layer 2 scaling solution, it's basically about taking transactions off chain. So as opposed to having transactions on chain, which have throughput issues, other issues. So layer 2 is primarily about taking transactions off chain. Now, how do you take these transactions off chain and still retain security of these transactions? That depends on what path you want to take. So if you're building a different kind of developer experience where the user doesn't have to be online all the time, then I would say Plasma sidechain.
If the user doesn't have what?
Have to be online.
Okay.
Online all the time. State channels maybe that there is a online requirement, right? So you can think of different ways. And I'm not an expert in state channels, but that's one way of looking at it. There are various ways to solve this or implement layered solutions. I don't know if that answers the question, but
So if I hear you correctly, so a state channel is something that the user has to actively participate in. And a Plasma chain.
There are things like routing and stuff, which kind of takes the online requirement to third parties. But essentially, a Plasma sidechain doesn't have the requirement.
And I know a little bit about TrueBit, but where do you sit on that spectrum?
Between Plasma and state channels?
I guess nowhere, right?
Probably nowhere. But here we are. I think, for me, like, TrueBit is just a blockchain enhancement. So I think that's the definite. If there wasn't a layer 1, there couldn't be a layer 2, right? So that's going to be like, I mean, I guess you could also say that the other question is how do these things fit together, right? The original Plasma paper says, well, you can use TrueBit to resolve fraud proofs, which of course opens the question of what is a fraud proof. But yeah, I mean, and also another question is whether Plasma is a state channel. I think really, if we really want to do this correctly, we need to sit down and ask ourselves very carefully whether these
Let's not do this correctly.
I haven't seen it done, but yeah, I guess I was building TrueBit before the word, we were around way before the word layer 2 came around. I mean, that was just sort of, so I guess the question is, like, does the tool do the job? And so, can you compute stuff correctly? And so that's
right. So yeah, so scalability of computation is actually a pretty big and interesting topic, and you guys should look into this project. It's actually quite interesting. All right, Dima. So you guys are not Plasma. You use state channels, but you're not a state channel solution. Can you tell me a little bit about the difference between Geo as a project and kind of more traditional state channel solutions?
Okay. So we do use payment channels, and but our channels are a bit more complicated than regular state channels. So we use like composite channels, where the funds could be backed on blockchain, like in regular state channel, or also it could be backed by trust of the parties to each other. So it's like a bit more complicated.
So my understanding is you allow people to route payments through each other without a separate notion of an intermediary, and even use multiple assets in the same transaction.
Yeah, it's another complicated thing about our channels. So you can open channel in any asset you want, even it would be fiat money or any custom asset like kilowatts of energy or elephants or whatever.
Cool. Jason, so you work on state channels. Can you give us a little bit of an overview of the different kinds of state channels, not necessarily the kind that you're working on, but just give us like a little introduction to state channels. Sorry.
My name is Jason.
Oh, not Jason. Oh. I know Terry. Terry,
Yeah, absolutely.
Yeah, sorry.
Absolutely. So this is, I'll start from kind of the basics. This is not going to get too much into probably what my company's doing, but kind of normal state channels it started on Bitcoin with Light Network, and that was kind of the payment channels in Bitcoin, which were kind of the first time people started doing this off-chain payment transfer, which is basically the idea that there's something on the blockchain that we've actually posted a transaction on the blockchain, but then we can continue to transact between each other without posting to the blockchain until we want to close the channel. And so that you could, for instance, do micropayments. That was kind of the first application was, I do an on-chain transaction, I say I could send up to $100 to you. And then I can very, very quickly send you an extra 30 cents, an extra 50 cents over and over and over again until I run out of money, which is already really cool. But to me, the most amazing part came in when kind of using this sort of idea with Ethereum, where we have kind of a similar setup where we have a couple parties who are interacting, and they've done some initial setup on the blockchain, but then they want to be able to really rapidly interact back and forth. And they want to be able to do this while exchanging arbitrary value, while kind of calling arbitrary functions, and have kind of really complex smart contract interactions. So kind of one dumb simple example would be, let's bet on a game of chess. And we'll do an on-chain transaction, we'll put down our bets, and then play the entire game off-chain. And we can play it fast, and it's still secure. So that was kind of, that's where smart contracts came in. That's kind of the movement from payment channels to state channels. One of the big innovations in state channels and payment channels was using networks. So rather than having to do an on-chain transaction for each channel, for each time I want to interact with a specific person, I can instead go through an intermediary. And an intermediary who I don't trust. So if Alice has a channel with Bob and Bob has a channel with Charlie, then Alice and Charlie can interact without touching the blockchain at all, but with all the security that the blockchain would offer. And so then we get into complicated issues. There's routing, there's dealing with intermediaries, what happens if Bob disappears, and there's kind of a lot of complexities that start creeping in, but it brings us to this point where you might not need to make an on-chain interaction for weeks, even with actively using a blockchain and using complicated smart contracts. The two main, there are kind of a number of variations there, but I think all of the solutions have kind of that as their fundamental property, using those same techniques.
Cool. Oleg, so tell me a little bit about your work with Polkadot.
The way we work with Polkadot is whenever the creation of sidechain, not state chain at all, sidechain, and eventually with bridges, to interconnect the mainnet and the sidechain. And the problem we have with that, what we have to propose and what we have to manage is proof of authority. Because of course, if we want to gain scalability and throughput, the sidechain does not need to use the proof of work protocol, which is quite easy. They can propose they can use something else, and they can use the proof of authority, and this will help us to propose blockchain consortium for company finance. This is why we use
blockchain adoption for enterprises.
Yes, absolutely, yes. And the advantage is that there may be some, you can take some money from mainnet and then this...
So Polkadot is already a multi-chain system. So are you a layer on top of that, or are you providing...
No, we use Polkadot.
You just use Polkadot?
Yeah, we don't specifically make any effort on this research field.
Okay.
We use Polkadot. Sometimes we do some request to Polkadot. That there is a bug or something like that. But mainly we use this sidechain solution.
Gotcha.
This is how we...
Can I ask you a question?
Yeah.
How did you decide to use Polkadot compared to using Cosmos?
I don't know.
That's a topic for... that's a topic for a different call.
Honestly, I don't know. There was certainly a good reason, but no, I don't know.
The Cosmos versus Polkadot fight is in a different day. Oh God. All right. So what I personally wanted to talk about also when I was kind of thinking about this panel was talking about adoption and user experience. And I actually want to dig into this problem a little deep today. So who wants to start talking about actual user experience of people using, let's say off-chain payments?
Okay, so at Matic actually, user and developer experience have been like a big focus area for us. So when we kind of started designing this, we had, so initially if you know the internals of Plasma, so it started out with UBXO based. And so we built like an account based implementation because primarily developers are happy with developing an EVM like environment. But what it also enables is that because Ethereum has been around for 4 years or so, there's a lot of patterns on user experience, on key management, on how to access apps that have kind of matured or are kind of maturing on Ethereum, and a lot of other blockchains don't have that yet. So some things that we've done is like we did the first implementation of Wallet Connect. It's like browser to mobile wallet protocol. So instead of keeping your keys in the MetaMask wallet in each device, for example, your private keys remain on the wallet. You do you scan a QR code when you're interacting with the app, and whenever there's an interaction, notification pops up on your mobile device, right? So that's one way of kind of making it simpler for new users, right? There are various other user experience related measures that we have been experimenting with. Things like gas abstraction for those users.
Well, the fact that some, say channel payments simply do not require gas.
No, I'm just, so yeah, I speak from my viewpoint. so things like those, maybe I'll let others chime in.
I just wanted to say two things that I love to list as like the ways that layer 2 solutions are huge for usability, even if scaling doesn't matter. The first is time to finality, or latency. So how quickly can we confirm your transaction? Regular blockchains, it sucks. Like as a user, from a user experience standpoint, if someone's using your app on your website and you say, cool, okay, you took an action, come back in like 5 minutes and it's relatively safe. That's awful. The other thing is onboarding, where if somebody visits your website and you say, okay, now go sign up for an exchange and like go through KYC and link it to your bank account and all that, and then come back and then pick up some ETH and then use my app. That's not ever gonna, that's not gonna get adoption. And so sidechain type solutions where you can kind of provide free access without having to go on the actual Ethereum network are a huge boon.
Do you want to talk about usability a little bit and user experience? You can say no.
Frankly speaking, we didn't think about user experience while developing our protocol, and then when we developed it, we just was like, wow, we should do a lot of stuff, and we should use a lot of resources to build all these front ends and all this stuff for users. So what I think that the situation with user experience is for all blockchain solutions and especially protocols is quite complicated because of that.
Well, also in a peer-to-peer network, it becomes a little easier because unless you're talking, like if you're not talking to blockchain, if you're just having the trust lines, then the key management becomes much simpler, right?
Yeah, it's actually better and easier to do for layer 2 than for common blockchain, but it's still a huge amount of work to do.
So since you're already holding the microphone, let's come back to the. Oh, you wanna? No, sorry. Go.
I'll dive in.
Dive into user experience. Right?
User experience. Yeah, so I guess keep in mind who our users are. Is in layer 2, it could be developers, but I guess it could also be end user. But I think you want, I don't know, 4 things like if we make it cheap, make it efficient, like fast, familiar, and maybe.
Well, it's good when people don't lose their money randomly.
Yeah, well, security is that's fine. Okay, fine. So we have. I filled the whole hand, but I mean, like, familiar for a developer might mean using like a familiar programming language, for example. So we've gone in TrueVideo making sure that you can issue tasks on C, Rust. You don't even need to necessarily learn Solidity to use the system, even though it's supposedly. Well, it does solve, I guess, a complex problem of Ethereum, and then make it efficient, as Harry was saying. But in our case, instead of using an interpreter, which is slow, we can use a JIT compiler, which is much faster, and use tools like IPFS, which are easy to use.
So your audience is developers.
Yeah.
Which makes life easier, right?
In some ways, it does. Yeah, I guess. We get to spend more time with each one, I guess. So.
All right, let's get back to payments and talk about multi-asset payments and kind of the question. Let's Dima. So let's talk again a little bit about what multi-asset payments bring to the picture, and also you guys talk about atomicity of transactions. And that also relates to multi-asset payments and how do these things work together?
Well, everyone actually is aware of this interoperability problem of blockchains, but also it refers to layer 2 solutions as well. And I do believe that providing micropayments with multi-assets will...
Give like an example of that.
Okay, I will give you an example of transaction, of atomic transaction in geo networks. So each node can have like exchange rate, and the channels are multi-asset, as you remember. So if I want, for example, to send, to pay from USA to China, and the merchant in China wants to get money in local currency, I can send one transaction in US dollars, and it can be exchanged on the way. We are up to, I don't know, up to 5 nodes. It could be exchanged to Bitcoins and to Ethereum or whatever. So our routing algorithm will calculate the best exchange rate, and the receiver in China will get his money in local currency. So it's just like example.
Well, the one I like personally from your documents is also paying for electricity, where you can exchange a kilowatt hour for like USD in the same transaction.
Yeah, for sure. I can do it.
Yeah. All right. I don't want to get too long and too technical because like it's blockchain week and everybody is tired. So we have actually a really broad, like actually every one of these people can probably talk for a couple of hours just about their specific like projects. It's a shame that we only have like a few minutes, but maybe if anybody in the audience has any questions, let's take maybe 3 questions and wrap it up. Go ahead.
Okay, we're talking.
Wait a minute, please. I'll take the microphone. Can I have one?
Hi, I was wondering if Jason can speak a little bit about the WOW token and the Dodge Ethereum bridge, which I kind of think is similar to the Geo protocol, which allows, using multiple assets.
That's a good question. I would like to to split these side by side. Originally the reason we created the Truman protocol was so that we could build a bridge between Dogecoin and Ethereum. And the problem is that you couldn't...
Specifically Dogecoin and Ethereum.
Well, yeah, specifically because of the escrow proof of work was like, we know that it's hard. You can't do it with a regular smart contract. Vitalik did it. I remember his demo was like 370 million gas over 118 transactions. So I guess if you're rich and patient, anything is possible, but you still have to break it down, and it's not a great user experience. That was the idea, that you'd be able to lock up your Doge inside of Dogecoin and then generate a WOW token on Ethereum, do whatever you do with WOW token, and when you're ready, you burn that token and unlock it. It might have changed hands, of course.
Fascinating.
Thank you. Yeah, so then, of course, what do I mean by lock? So we can go down the rabbit hole here, but I guess I can also say, I think this is very different from the Geo approach. It should be...
Yeah, and it's also for a different purpose.
I guess. It's maybe a different purpose, but ours is also very crypto specific, right? You're not going to get changing fiat dollars through the Doge Ethereum bridge.
Yeah, exactly.
But it is a way of making tokens.
But did you do it? Are you actually able to transfer Doge from Doge to Ethereum blockchain?
We can check Scrypt proof of works inside of TrueBit. In fact, we packed them, into. We wanted to make it more efficient, so we packed them inside of a bulletproof. So we're using bulletproofs for efficiency. At least that's the idea.
Which is that what you guys are doing is you have like a token on Ethereum, which is like equivalent to one Doge token. And so like you basically own a Doge token, but you can use it, it's an ERC20 that you can do stuff on Ethereum with, as opposed to just atomically safely trading tokens. So like you could like say I want to exchange an ETH and a Doge securely at some exchange rate. So it's like two pretty different problems.
Yeah, and the trust model is completely different too.
But the purpose, like, I mean, you're trying to, we're transferring consensus over the coin from one network to another. It's not just about exchange of
Can you redeem it back?
Of course, it's WayPay, you have to be able to redeem it. And the other thing is, paper talks about, there's no, also, you collateralize it on the ETH side, but what if the price of ETH goes up and down? So we do this all without, some calling to some cheesy oracle. Like it's really decentralized. So we actually parameterize the WOW token so that you have, based on, it's safe up to specific exchange rate.
We have cheesy oracle sandwiches in the front.
Thank you.
All right, one last question.
Forgive me.
That'd be great, thank you.
So somebody was talking about the difficulties of user onboarding on layer 1, where you kind of have this problem of like, hey, what's a private key? Get a private key. Oh, get a Coinbase account, get money. How does that change with layer 2? Why does layer 2 make that better?
Well, so that was what I mean. So one big thing you can do, for instance, if you're using Plasma, and Plasma has an operator, and they put all the transactions in for you. You don't need to put anything on the network. You don't need to pay gas. And so if on this Plasma chain, for instance, the operator can just gift you some token, which is like the app token. So essentially they can front you, 5 units, so you can start using it, all without any on-chain transactions happening. So you need your private key still, but you don't actually need to pay any gas on Ethereum. And that's the big distinction, is being able to interact without paying any gas.
Yeah, I mean, concur with this point. His point is also applicable somewhat on layer 1, where you can do gas abstraction. But on layer 2, the model is much more simpler. You can do experiment with a lot of things that are not possible on a rigid layer 1, if I may, because design space is open on layer 2. So it's much easier to experiment with these approaches, and that's why we do a lot of stuff.
All right, thanks everybody.
This is fascinating. That's very with what? With those.
Did Doge ever do their hard work that they needed to do to enable the...
Guys, we have 10 minutes break for pizza, and then we'll get back to our second panel about micropayments. So please be here.